Nice to meet you all. And I hope I do get to meet some of you afterwards. Please come and talk to me. I'll be here for a couple of hours if you want to chat about anything we talk about today. Very excited to be here. This is the first time I've talked about GitOps in front of a group of continuous delivery experts. So I fully expect you to think that several of the things I'm saying are, either wrong or old hat or both. But feel free to say so, although I'd prefer it if you did so at the end, because I've got quite a lot of slides to get through. I hope we're going to have a sort of fun tour of the core concepts of this GitOps thing that we've been talking about at Weaveworks and others as well. A little bit about Cloud Native and the Cloud Native Foundation, and then a bit more detail about GitOps at the end, depending on how fast we go. My name is Alexis Richardson, and as Bjorn said, I'm the CEO of Weaveworks. Previously, I ran Spring, Rabbit, Redis, vFabric, did some things with Cloud Foundry, OpenStack. So I've been involved in a lot of open source projects, but I didn't personally become very familiar with continuous delivery as a practice until starting Weaveworks a few years ago. But this is because Weaveworks is the first company I've done where we've actually really taken seriously the idea of operating a service. And I wish I'd done that with RabbitMQ, because we kept on getting these sort of issues reported by users, and they would say things like, I do this and this goes wrong, and we just wouldn't believe them. If we'd actually used our own software, we might have found out some of the things that users experience. So it's a really good idea to use your own software, to dog food your products, especially if you're a vendor. And you get into a completely different habit of thinking about systems. And one of the things that we do at Weaveworks is we run a SaaS. We also write a lot of open source projects that you may have come across, like WeaveNet, or work on Kubernetes and Prometheus. But running a SaaS and doing so for several years on new technology is a kind of frightening experience. It is a bit like, being in a race with a ship made out of wood and sails made out of tissue paper. You're constantly running around keeping things going. And I got excited about GitOps when one day, a spring morning, the birds were tweeting in London about 2 years ago. One of the developers said, I'm about to make a change, which will probably wipe out all of our systems. I thought, wait a minute, this doesn't sound like... So as I stood up, sort of, no, like this, I heard a click, followed by an oh, and then shit. I've wiped out all of our systems, and this is a global wipeout, lots of different zones on Amazon, and staging, and development, and production. It was a bit of a catastrophe. Anyway, what was great was then the whole team sprang into action. I'd never seen this happen before. And within about 40 minutes, the whole system was up again. We were taking customer requests before and after the crash. And I was quite impressed, because it's a complicated system with lots of moving parts. And I said, well, how did we do that? And they said, oh, well, basically, everything that we run is already described in Git. Not just, the state of the cluster, but also the machines, how they're provisioned, how the networks are set up, all of our health checks, how our monitoring works, all of our dashboards, the app, the services, the user state, the lot. And that means that we actually have a complete description from which we can rebuild the system. And as we're building it, we can check it's correct. And if we deviate from the correct state just a little bit while we're setting up the system, we can get back on track. Which means that when we bring it up, we can bring it up very fast and correctly. And I said, well, that sounds useful. We're now down to 5 minutes, by the way, for similar scenarios, obviously not including the data. And I said, what exactly is it that lets us do this? And they said, well, it's because we've got a description of everything in Git, but also because everything is tied to one single control loop and pipeline combining both monitoring, build, and deployment. And I said, well, that sounds like something our customers should be using. We've spent the last few years just basically taking that idea and turning it into product, because that's something that's incredibly useful to everybody else. And I should also say that if you're not using Kubernetes and cloud native technology, a lot of these things are probably ideas that are slightly out of reach, because one of the things about Kubernetes is it's a different kind of system in terms of how it works, and I'll explain why. So if you see things here that resemble things that you do with VMs and normal machines, be aware that there's things about Kubernetes that have changed the game a little bit, and I'll try and show what that is. So I'd like to introduce you to this team, Cordoba, who's one of our customers. They do a marketing product using technology where their customers need to have lots of websites around the world in different languages, which are used to sell things like shoes and clothes and other retail products. And they've decided to build a business around machine learning to optimize the language on each different site so that each time a new product comes out, businesses can roll out different sites in different languages very fast, and they can tune them based on watching user interactions. And so they've got a lot of data scientists in the team, but they were spending all of their time doing deployment, or rather all of their time thinking about infrastructure, plumbing. When they actually tried to do a deployment, everybody would stop working and press the big deploy button, and they would wait, hoping that it wouldn't fall over. Because if it did fall over, it was often in a partial state, which would require them to redeploy everything from scratch. So they didn't have a feeling of moving very quickly or confidence to work quickly. They'd already adopted Kubernetes on Google Cloud, and we started working them and got them to a state where this is their original velocity in the dotted line. They were making 1 or 2 deployments a week across the whole team, and by the end of the process, they had 4 different teams. They split the team up into 4, and each team was doing at least 30 deployments a day, which meant that these 2 lines, the green one and the red one, are the aggregate of issues fixed and customers responded to. Their total speed went up by about 2 or 3 across the whole team, which, if you can imagine, on a large team would be a huge change. And they did that because they moved from having a low-confidence environment where they did 1 or 2 deployments a week, which are fragile, to a high-confidence environment where they did many deployments a day independently in each team, which are not fragile. By not fragile, I mean if they broke in a clean way and they could understand how to get back on track, as opposed to, oh shit, we don't know what state we're in, we might have to redeploy everything from scratch. And that's really, really scary, because that's potentially quite a long outage. So that's quite a big benefit, and a lot of it comes from using technologies like this. This is what's called a YAML file. Who has seen one of these before? About half of you, okay. So YAML stands for yet another markup language. All of this is just statements, facts about a system. This is a particularly trivial system. In fact, you can see here there's an Nginx front end running in a container on port 80, and there's a PHP thing which is called RSS reader. There are 2 containers in this example. What Kubernetes does is it can check whether those containers with those names doing those things are running or not. And if they are not running, it can start them up for you and reconnect them to the places where they need to be connected to. Which means that if you are willing to cede a degree of control to Kubernetes, it will orchestrate the running of your application for you. And it does so based on these declarations or descriptions, statements about your system. And when we talk about GitOps, we're essentially saying you should take this approach and use it as much as possible for everything, which isn't the same as saying you should automate everything, because sometimes important things need to be manual. But it's nice when the system says, I think you should do this, and you get a chance to say yes or no. Or this is ready for deployment, click here to go ahead. It's also nice when things go down and they come up automatically, because you can sleep through the outage. And another thing that we're doing with this stuff I'm talking about today, GitOps, and this is very, 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 very important, is we are building on decades, well, at least a decade, of DevOps best practices. Here is a timeline that I got from the interwebs showing, this will all be familiar to you lot, but here's Andrew Clay Schaefer talking about, he was the first person, I think, to talk about DevOps. And who else is here? There's arrival of tools like Chef and Puppet, the first DevOps days in Belgium. For some of you, these are probably etched on the bedpost. But we're now in the era of Kubernetes, so we're trying to reapply these concepts to a world where everything can be described. And when you can describe things, you can automate them. That's the key. And GitOps is an automation technology, an approach and process and philosophy for cloud native, which is a general term used to describe tools like Kubernetes and Prometheus and so on. And I'll say a bit more about cloud native later. If you have a description of a system, you can build to that plan and check whether it's correct, like in a factory. Oops. Okay. So much as the original cloud, Amazon in 2006, 7, and 8, led us to DevOps, cloud native, which is an iteration of cloud, leads to GitOps, which is an iteration of DevOps. And key concepts here are that we're trying to push code, we're trying to have developers feel comfortable about making changes through Git, giving them control over operational constructs. And that in turn means we can do operations by pull request. This is not the same as saying that I can deploy my cluster, trigger a deployment by making a pull request. This is truly actually running a whole operation through Git. It's a slight change. So what did we learn from 10 years of DevOps? Config is a very important part of your system. That is a form of code, so it should be version controlled, just the same as code is. Because what can be described can be validated and automated, if you describe everything and keep it in version control, that gives you a mechanism for keeping the correct description of your system in version control and using that to automate the whole system. So GitOps is just a portmanteau word combining the Git, which is a developer tool, with operations. We're saying that Git, and you can do this with other source control systems, but Git is a source of truth for the desired state of the whole system. Okay, so this is a very important concept. Source of truth and desired state. Source of truth is, if people disagree or observe different facts about a system, where is the place that we go to enforce agreement about different operators and different people controlling a system? And the answer is we go to the single canonical description. It's the law about the system, passed by Parliament just across the road. Secondly, it's the desired state. Now, what's actually running in your system may not be the same as the desired state. The desired state is one of the things that you would go back to if you had a crash, wiped out the running state. The desired state is the last known good state that you want to go to. Okay? So it's not the same as the observed state or the actual state or any other kind of state. It's the desired state. It's a snapshot. Which means that if you want to change the desired state, you need to update Git. If you just make changes to your running system without changing the desired state, you've got a discrepancy between your running system and your desired state, which means if you have a crash, when you rebuild, you'll go from your desired state. So think about that. And yes, it's the whole system, the machines, how they're provisioned with the operating systems, how the clusters are laid out, what's inside the containers inside the clusters, what applications you're running, what services you're running, monitoring, dashboards, everything else. Secondly, so I said there's a desired state. There is also actual state. You have a control loop, which is constantly monitoring both the desired state and the actual state, going backwards and forwards, and comparing them. And if, or rather when, it sees discrepancies, it has the right to pull changes from the asset repositories and config files and pull them into the running system, and then inside the running system, use those assets to enforce changes to the running system, to realign it, to synchronize it with and reconcile it with the desired state, which is called orchestration. So what this is saying is the way that you manage a system, both in terms of cluster operations but also things on top, should ideally be done through orchestration by running processes that take the desired state and use it as a set of instructions for what the running state should be. Secondly, as part of point number 2, the updates are not full cluster redeploys. They can be updates in place using the APIs of the cluster itself, which means you need to be inside the cluster to do them. And you are trying to make those updates atomic, which means, because typically when you make a change to a system, you're not just changing one thing, you might be changing lots of things. It is useless if you can only make half of those changes. You want to make all or none. They have to be atomic. So that complicates matters. Finally, they have to be convergent. They also have to be idempotent. Convergent means that you can continue to make changes to force the running state to be the same as the desired state. And that means that you can have this property that you can operate your cluster by changing the desired state and leaving the rest of the orchestrator. Finally, oh, sorry, hang on. You should also, when you finish making changes to the cluster, write them back to what's in Git, so that then you absolutely are certain that the running state and the desired state are the same. So now this label has been applied, or now this container is running, or now this other change has been made. So that means that Git is not only an audit log, it's also a transaction log. So you can think about changes to your system as a linear sequence of state updates in Git, which is a sequence of desired states, and a linear sequence of transactional updates on your running state. And that makes things very clear. It's unambiguous what's going on, and they have a clear relationship. Lastly, you have diff alerts. In our case, kubediff, ansiblediff, and teradiff tell us when Terraform, Ansible, or Kubernetes the running state is different from what's in Git, and it hasn't been picked up by the orchestrator. So that forms a kind of back-channel alerting system, which allows human operators and other bots, I guess, to step in and do things. Here's an example showing up in our Slack of a little alert saying that Kubernetes has diverged, drifted away from its intended state. Click on the playbook to do something about it, or click on the dashboard to see a nice picture of some metrics. And a lot of people are doing this. This is best practice. It's not unique to us. So that forces you to think about everything in terms of a control loop and a cycle. And this is the operational world in this new cloud-native environment. All day long, a developer who's in charge of operations as well, or doing DevOps, is just going to go round and round this loop as fast as they can. So Cordoba, who I mentioned earlier on, when they do 30 to 50 updates a day, it's because they're zipping around this loop all the time. And a lot of the updates are experiments. Hey, what if we make the website pink instead of blue? Will our hit rate go up? What if we change the text here? What if we do this? How do we do A/B? How do we do blue-green? And all of the updates are atomic. The developer experience is just git push, and you have, as a result, a best practice for continuous delivery for Kubernetes and things like it. And you can see some things have crept in here, like the concept of observability, which I'll talk more about later. That's very important. You can't do GitOps unless you integrate observing and measuring your system with the act of deployment. And I'll talk more about that later on. So in summary, what have we got to here? You can hire a new developer and make them productive with your running system just if they can use GitHub. Hooray! That's pretty cool. And all the changes are validated, stored, audited in Git, which means that you can pass audits in Sarbox and HIPAA and PCI without having to spend $20 million on some expensive Sarbox database. And that's really neat, because it's obviously with things like GDPR and other compliance, these things are becoming more and more important. So, oops, that box should not be there. All right, this is Kelsey Hightower. Who knows who Kelsey Hightower is? A subset of the YAML people. Good. So Kelsey's probably the most widely known Kubernetes sort of advocate. He summarized this concept late last year as, the whole world is envisioned as a repo, not an installation. And that's a really important mental shift from thinking about operations and installations and machines and clusters, boring, to the world as a repo, a description, what I want to have. Isn't that nice? Developers can understand it. And also, I can't mince words. Kubernetes is really complicated. Who's actually tried to stand it up? An even smaller subset of people. You should definitely all try Kubernetes, and if you do, try using Weaveworks with it, by the way. But it is a bit of a beast, and it's not as much of a beast as some things. It actually works. It does what it says on the tin, and there's a lot on the tin. It is worth using it, but the initial user experience is quite arduous. And once you've got it up and running, you think, well, wouldn't it be great if we had all these other things? I'd love to be able to just make a pull request, and then a URL is generated. So just go there, and I can see what I wanted to see. And it's got this API, which was written by people at Google, whose brains are far too big, and they decided to call it the kubectl API. And here's an example of the world of Kubernetes. People can't even agree to how to pronounce this word. It is a matter of ongoing debate. And you shouldn't use it. It's like SSHing into your system when it's in production. And wouldn't it be nice if you got measurements as you do deployments? So there's a lot of desiderata that this is meeting. Secondly, among the people who are using Kubernetes, or vendors like ourselves who are in the business of helping people to use Kubernetes, we actually use Kubernetes as well, but we also want to help you use Kubernetes. Here are some of them. A lot of people are doing GitOps and talking about it. Some people are talking about it, but not naming it. Here's an example of that. This is Sarah Wells, who leads, I think, one of the engineering teams at the Financial Times. This is a picture of her talking 2 weeks ago at KubeCon. There's a rather splendid thing on her slide there. I don't know if you can see it, but key metric for success at the Financial Times and the dev team is number of sarcastic comments on Slack. But that's good because it's a dev tool. It's developers communicating socially, are they happy or not? And it's essentially saying is developer happiness is a key goal because it leads to productivity, more changes a day, less stress, less drama around a deployment, that kind of thing. We're using it. Just a few words about us in case you hadn't heard. We're one of those VC-backed companies. We're here to help you go faster using new technology. Here are some of our team. We have a team in London, hooray, a team in Berlin and in San Francisco. And you might have heard of us for getting our mucky paws on some of these projects in the past. And we're all in on the CNCF. I was one of the people who helped get it set up. We've been running Kubernetes in anger for nearly 3 years, which is actually a long time. It's basically an eternity in cloud-native world. Have you seen those LinkedIn job advertisements? Kubernetes developer sought, senior position, must have at least 5 years experience. I told you the story about our disaster and the recovery. It really comes from doing this. Other tools that I haven't mentioned, Docker, of course. Terraform is a wonderful tool. It's a complete declarative way of specifying what's on your machines, which works not only in the cloud, but also in other cases. One thing that I didn't say is that we've tried as hard as we can to take on the discipline of the dev team, all being site reliability engineers. So they're all doing DevOps. There's no difference between them. There's no ops and dev. And any changes to the system, even during a production crisis, should go through Git. Which may lead some of you to wonder if you've been doing CICD for a long time. Doesn't that take ages? And the answer is, when you declare things, a lot of the time the changes you're making are just to config. There might just be a name change like dev to prod, or V1 to V2. So you don't have the whole rebuild cycle. You actually just redeploy the same stuff just with a different name. So that's actually a very low latency activity. Okay, so now I want to say a few things about cloud native. Okay. Cloud Native Foundation, part of the Linux Foundation. It's the home of Kubernetes and 19 other projects, and it's really there to funnel money from big vendors like Amazon, Microsoft, and Oracle, yes, Oracle too, to open source projects. And it's doing really, really, really well, and it's a great way of making these projects, get marketing, get support, get help, and other things as well. So I was in Copenhagen 2 weeks ago. This is a photograph from a late night bar that I found myself at. This awesome place. And Copenhagen is the home of Lego. So I'm now going to have a few slides involving Lego, because it was fun to do that. This was a Lego celebration of women scientists at NASA, astronauts there. So Lego is a great tool for creativity. And you've probably heard before people using Lego analogies in tech, and I will make no apology for doing so again. But it is truly amazing what you can make with Lego. And here's an actual car. Can you believe it? Here's an actual octopus eating an actual spaceship. I don't know what this is. So CNCF, just 2 years ago, it was basically a pile of Lego bricks, or perhaps just even one Lego brick. We've tried to get to the point where you can at least build an application now using Kubernetes, Prometheus, etc. What are we doing? We're building a cloud platform. That's what we're doing. I'm going to talk about platforms a bit now. What is the goal of the platform? It's for the era of these kind of ubiquitous services. Now, what's interesting about this is the last time something like this happened was the 90s when the web appeared. So you may remember that. Some of you may remember it. I remember it, unfortunately. That was the last time that all the tech companies and end users were sort of all pointing in the same direction, trying to do the same thing. Because it was so important that actually it just didn't make sense for HTTP and HTML to be owned by a company. Can you imagine what would have happened if they had been, the Microsoft web? Actually, we did have that briefly beforehand with the AOL era and CompuServe, the sort of separate internets. But pretty soon people realized it made sense to use open standards and open tools and common open source software. It was really the birthing ground of the modern open source era. And everyone was on board to make it happen, and it led to a tremendous innovation in terms of consumer services, business services, government services, and so many other things which just wouldn't have happened if it had been owned by a company. And we've seen a lot of things after that, like SOA and web services and God knows what else. I can't even think about it. But all of those didn't succeed because they were not adopted by everybody. There was no incentive for everybody to pull in the same direction on the kind of core infrastructure. And that's happening again, which means you're going to see this era of boom all over again now, except it's going to be tied up with devices, things, talking chairs, intelligent toilets, robots, cars, the lot. Okay, it is pretty terrifying, but let's get to that later. And for business people, this is a real opportunity to spend money, so it's important to understand what's going on here. And one of the things that's happening, and I think a theme for today, is these new technologies are helping you to go faster. This is important. So those of you, has anyone used Hadoop? Come on, admit it. There's one guy there. Another one. And someone at the back. Someone at the back, 4 people. So this is an actual photograph that I took on a Hadoop project in 2013. It was at a large bank which will remain nameless. If you got people excited about big data, then usually that involved having a meeting with the CEO and saying, we're going to use big data, it's going to be amazing. And the CEO would nod because they'd read about it in the Harvard Business Review on the plane overnight on the flight back into London. What are we going to do with it? We're going to analyze our stuff. It's going to be amazing. Okay, great. We're going to unlock the hidden value of our customers. So what are we going to do that? We're going to have a POC. What's that? We're going to get Accenture in, and we're going to have them compete with PCW to tell us which Hadoop distribution to use. It's like, oh my God. Why don't we just get it from Apache? No, that would be too easy. So people would seriously spend months and months and months just getting lots of different competing versions of Hadoop set up so they could do some simple app like fraud detection, for which actually Hadoop was probably a sledgehammer for a nut or something in the first place. So you can see how this is a recipe for getting things wrong. It's not to say it was a bad thing to do, but it's a really great opportunity for sort of misaligned expectations. Well, you said this was going to do fraud detection, and it'd be ready in a week. It's been 6 months now. Why do we need a new data center for this? Today, you can do machine learning using the same software that Google wrote in under 5 minutes by installing TensorFlow on GKE, which is the Google Kubernetes engine. Now, I'm not saying that's a clever thing to do. It might be a really, really bad thing to do. But I will tell you, it takes 5 minutes to do, and that means that you can check if you actually need it within 5 minutes. And if you decide it's not for you, you can go and do something else, like sit in the sunshine, scratch your nose. It's a lot better than spending 6 months figuring out that Hadoop was the wrong tool for the problem or something like that. So we're in an area where business expects IT to test things out very, very quickly and report back more or less continually on what the hell's going on. So it's very important that things move quickly. So how are we going to do that? So here's something that you might have heard of. Who's seen Simon Wardley talk? One or two people. Simon loves to talk about this stuff. He's a great advocate for these concepts. I'm going to talk about componentization. Componentization, which is invented as a term by Herb Simon, an American sort of economist, scientist, overlord type person in the 60s. And componentization basically is what's responsible for things like this. This is a screenshot from the Guardian, the Graniad. This is an actual real thing. A photograph, it's actually a video which I can't play here. A video of a skyscraper. If you play the video, you'll see a sort of speeded up movie of the skyscraper being built. A Chinese construction firm in under a month building a big building. How on earth is that possible? It's amazing. The answer is all the components are completely standard and they work together. And if somebody supplying one component disappears because they go out of business or something is late, you can get it from somebody else because there's usually several people doing more or less the same thing. That's amazing. And you have patterns to build buildings out of these components. And here's an opposite example. I don't know if any of you have seen this book before. It's by a gentleman called Thomas Thwaites. Inspired by this quote from Douglas Adams. I don't know if you can read it, so I'll read it out. This is from Mostly Harmless in 1992. Left to his own devices, he couldn't build a toaster. He could just about make a sandwich. So this guy read that and thought, I'd like to build a toaster. That can't be hard. So he decided to build it out of organic parts. He didn't actually want to source any components. He just went ahead and built it. So he made all the pieces. And it took him about a year to build what's on the cover there. He didn't, the electricity wiring was made by hand and things like that. Once he turned it on, it exploded, which is why it's melted on the cover. So obviously you don't want to do that. You want to use a platform made out of components because that means you can go fast. And it's easy to get started. And one of the characteristics of these platforms is an explosion of things that happen on top, higher order systems. Because people stop bothering to build the infrastructure. And here's something from the Puppet Lab State of Continuous Delivery report, which I'm sure you will read avidly, from 2016, basically pointing out that if you do things more frequently, your overall business metrics will improve. Hooray. Remember this chart that I showed you earlier. So if I want to go faster, what do I need? Well, first of all, I need developers. They need to write applications. But I need a platform, and I need a way to use it. And that brings us back to continuous delivery. So what is this platform? Just a few words about that. I hope this is interesting to you because this is sort of weird stuff about cloud native that is not strictly part of the core thesis of the conference, right? That's okay, I have permission. So this is the new cloud platform that is emerging, showing the role of Kubernetes and why you might want to think about continuous delivery for this world. It sits on top of things like AWS or your machines on premises, your own data centers, alongside other CNCF projects, and it lets you run applications on top. And obviously, for each different place that you set things up, there might be local services, like if you're on Amazon, you have SQS and RDS, but if you're on Google, you have PubSub and Spanner, whatever it's called, Bigtable. If you're on a mobile phone, you might have something else. Obviously, the data is there too, but once you've got the platform in place, you can just run code on top of it. And already, we can see lots of people, this is a rather shopping list kitchen sink slide, but we can see lots of different things that people can run on top of Kubernetes, demonstrating that it is indeed an example of a platform, because this has happened very quickly. An explosion of higher order systems for productivity and velocity. Which brings me to serverless briefly, because everyone asks about serverless. Who's using serverless? Some of you, more of you than about the same as Kubernetes. So these things are going to converge. Serverless is basically the latest iteration of platform as a service. One of the things that people like about it is that you just deploy some code onto Amazon and you only get charged when it gets executed. And this kind of model of, I've got some code, I want somebody to run it for me, is kind of where we're going in the long run with the cloud. So this is just, a roadmap for the CNCF. that I thought some of you might be interested in. At the moment, we're very focused on security and storage. And we're starting to look at CICD with things like GitOps. Once we've got that out of the way, I think we're well onto the way towards just run my code, please. And that is the cloud platform's purpose. Just run my code. More Lego for you. Okay, so when you have new technology, you also have new practices. They tend to be tribal. You guys are a tribe, continuous delivery people. There are some similarities among you, I can see. Practices people agree on, words people use, things people do. You meet somebody else in the tribe, you already know what they might be thinking about certain stuff. You also have tribes excluding each other from practice. So the serverless people poo-poo their predecessors in a rather infantile manner, which is really fun to be part of. So to go back to this point, GitOps represents an encapsulation of the core ideas of DevOps as applied to the era of serverless and Kubernetes, a tribal terminology. So to summarize, velocity, platforms that work anywhere, lots of things that run on top of them, like machine learning, serverless, and what have you, and a simple way that makes sense to do delivery. Okay, that's the cloud native bit. Now I'm going to say a bit more about GitOps because this is a continuous delivery conference. Go through each of these things in turn. I'll try and do it fairly quickly because there's quite a lot here. Let's just go back, actually. I'll talk about why Git, what's in Git, what do we keep in Git, a bit about pipelines and security, a bit about observability, and then a little survey of tools. So just to recap, building on DevOps, single source of truth. Doesn't mean a single repo, a single source of truth. You could have several repos. Everything's version controlled. Trunk-based development is preferred for those who want to know about that. Try and do everything by pull requests frequently, and small changes are better, hence trunk. Rollback and audit logs and transaction logs provided through Git. And you can restore from there as well. So, canonical source of truth. People write to Git. There are also software agents updating Git. They're updating Kubernetes and writing back. It's a clear model, nice and easy to understand, with a number of clear benefits, including that you pass compliance essentially for free. It's also very good for understanding issues that are really compliance issues, but actually play out as social issues within development teams, like, I don't understand this change in the running system. Who made that change? Let's go and have a look in Git. Oh, yes, I see that Josephine was in that day, and she made this pull request, and it was merged by Bob. And here's a little note in Git explaining why this is here. And now I can think about that as another developer in the team. And we apply this to as many things as we can. Anything that we can describe, we can store, and we can automate and control. Hooray. So here are some examples of that. There's nothing, these are more to be kind of gazed at rather than read. Here's a picture of the dashboards in Grafana Lib. Some YAMLs. Istio for canaries and traffic routing. More Istio. More routing. Redirection for fault injection, etc. Pipelines. Here's a pipeline with the observability loop. A typical CI/CD pipeline involves CI doing writes into the cluster through an image repos. Whoops. With GitOps, we have a firewall between CI and CD, implied by all the repos. CI never accesses the running cluster. Gives us a separation of concerns. I call it being pull-based. So you have dev going round like this, doing builds and tests, and then you have a set of immutable artifacts in repos, images, config, and so on. And then you have a totally separate CD system which pulls changes out of the repos when it's notified of a change. So actually, you end up with this kind of pipeline instead. As you can see, the Kubernetes cluster and the other associated moving parts only get to talk to the repos, separate from the CI. So this is a more secure model, and there's a blog post about this on the Weaveworks blog, Compliance and Security. And I've just been told I've only got 5 minutes left, which is a bit of a surprise. I've got 10 minutes left. Okay, great. That's good. When you run your update mechanism from inside the cluster, what you're doing is you're saying the CI system, which is a well-known vulnerability, cannot interfere with what's running in the cluster, and that is a much more secure place to be. So don't do what I call CI ops, okay? And one of the things that people get terribly confused about is doing CICD using a CI tool. I cannot tell you enough times, don't do this. So Kubernetes makes it easy by letting you run something called an operator, which lives inside the cluster and can do things like synchronization with Git, and then write back to an audit log. And anything that does not write back and record changes is harmful because you can get discrepancies between your desired and actual state. It's very important that you can make those changes atomically. If you make half a group of changes, that's not a correct change. Break up your repositories intelligently. A good idea is to have at least one per service. Separate config from code so you can get triggered on config changes as well as image changes. Separate branches per environment, dev and prod, for example. I will, by the way, share these slides afterwards in case anyone wants to get a copy. So the core principles: declarative configuration, Git review for changes, never push directly to the cluster, don't use CI for it, except in dev, obviously, and use an operator to synchronize and drive the cluster state to the desired state. Benefits: atomic transactions, no partial mysterious changes that need to be rolled back completely, which leads to a huge uplift in velocity, trust me. Transaction logs, so you get audit and compliance, and the security firewall that I mentioned. Some people ask about secrets. You can do secrets in this way using something called sealed secrets, invented at Bitnami, which is pretty cool. Basically means that you're passing around encrypted secrets. So a few words about observability. Observing what's happening and knowing that you've done a correct deployment is part of the process. It's not a separate thing. Okay? John Arundel, down in Cornwall, on Twitter here, never accept a pull request if you can't verify that it does what it's supposed to do. This seems like obvious in retrospect. So we have the cycle again. Declare, monitor, deploy. We also want to be improving the user experience as part of the deployment. Measuring whether when we make a deployment, it's benefiting the user. Is a latency too high or too low? Are we improving that? A whole collection of tools that come together as a dashboard. This is another thing you'll see with GitOps systems, is aggregated dashboards combining metrics, events, logs, traces. It's very important. So just to recap, only what can be described can be automated and controlled. Only those things. The last takeaways on GitOps, before I have a few tools. Great developer experience based on Git push. Push code, not containers. Okay? It's about more than just triggering a cluster deployment. It's a full operating model for the whole stack. Full operating model. And it's not the same as just driving everything out of CI. For example, the firewall concept that I mentioned. So an evolution, but also a change. I think that's the takeaway here. For sort of simplified version of that, faster, better, and safer. So just very quickly to end up tools. You've got these choices. Okay, you can do it yourself, which is always fun. You can do the CI ops approach, which I've spent several times telling you is dangerous. You really need to know what you're doing around security if you do that. You can use an off-the-shelf PaaS, a platform as a service, like a Heroku or a Cloud Foundry. That tends to be really good for the code push rather than containers, but often at the cost of actually constricting you in terms of the flexibility of the application. And if you don't want to be constricted, you have to use one of the modern dedicated tools. Here's a list of some of them, okay? Weaveworks is in the middle, that's the one that we do. This is not an either-or list. You can use a lot of these things together, in fact. So I'll just whiz through them fairly quickly. Spinnaker was created by Netflix for Netflix. And when I say that, what I'm saying is it kind of dates back a few years. It's really about VMs, not Kubernetes. And it does a number of things that make it somewhat unsuitable for what we consider to be GitOps. But it is a pretty awesome tool if you're doing the kind of things Netflix do. It's very, very powerful. But flip side of that is it's very, very complicated. Helm. If you start doing Kubernetes, you'll run into Helm. Helm is a great way of socializing apps on Kubernetes around the rest of your team. If you're the expert in the room and you've got it all up and running, get people using Helm to deploy apps to it. It's nice and simple. Problem is, it doesn't have a whole load of safety properties. It's not atomic, it's not deterministic, it's not compositional, which means it's quite dangerous to use unless you've got a way of checking that it's making correct deployments, which is why combining it with a GitOps approach is a good idea. So you can use Flux for that, which is something that we wrote, similar to Spinnaker, but Kubernetes native, really aimed at containers and objects inside Kubernetes rather than virtual machines. Unlike Spinnaker, it keeps a complete record of every change in Git. So it really is a native GitOps tool. GitCube is doing the rounds. GitCube is a great name, but kind of doesn't have a load of production features, so it doesn't write back to Git, for example, which means that you can get drift. It's not atomic, which means that it's unsafe, but it's great for dev. And these are some other things that you might run into. The Jenkins team have got a great new thing called Jenkins X, which is GitOps. Scaffold is a new tool from Google for assembling these things into sort of dev frameworks. There's lots going on. And briefly, our own product, which I just want to show a few screenshots of. I just mentioned that all the previous tools are open source. This is a commercial product, so this is an advertisement. Throw things if you wish. You get screens like this showing you the history of your updates, and you can roll backwards and forwards. Here's a history of one particular service's set of commits. You get to immediately look at what's happening in your deployments, and you get to verify whether certain facts about it, metrics and so on, are what you want them to be. Are they improving or making things worse? Anything missing from this? Developers, of course. You've got the platform, you've got best practices, you're left with developers. That's you, by the way. I very much hope that you all go and enjoy trying out GitOps, doing continuous delivery in this way, and feel free to ask me questions afterwards if any of this did or indeed did not make sense. Thank you very much.